In this video, I want to look at the commutative property of multiplication. This is the property that a times b is equal to b times a. I can switch the order of the things I'm multiplying. And given our definition of multiplication, this may not be immediately obvious why this is true. Let's suppose we have 3 groups of 4 cookies. Our current definition of multiplication says we look at the number of groups times the number in one group. So 3 times 4 would be our total number of cookies. If we draw a picture, here's 4 in this group, 4 in this group, and 4 in this group, and we have 12. So how can we see that that's the same thing as 4 times 3? How can we see that these are the same? Like I said, it's not as obvious when we think of it in terms of this group. Why can I switch the number of groups and the number in each individual group? Well, let's reorganize this group. I'm going to take this group of cookies and I'm going to put them in a row. This group of cookies here, I'm going to put them in another row. And this group here, I will put them in a third row. So now I still have my 3 groups of 4 cookies. But this is now a 3 by 4 array. So now I can group vertically instead of horizontally, and I will have 4 groups of 3 cookies. So I would get 4 times 3. In doing it this way, regrouping like this can help us see how this commutative property holds for other numbers as well. I also want to think about the commutative property in terms of areas and why it might be true. So first, why is it that multiplying the length times the width of a rectangle gives me the area of the rectangle? Let's consider this rectangle here, and let's suppose this is 3 inch by 2 inches. The units in area are given in square units, so it's given in square inches. And a square inch is a square that is 1 inch on each side. And it would be the area of this square that is 1 inch on each side. So when I think about my rectangle up here, the idea is I'm going to break this up. This side here is 2 inches, so each one of these would be 1. And then I can break it up again. My picture's not great since these are not equal, but we'll pretend they are. And break this up into 3 equal pieces. So now each of these blocks is 1 inch by 1 inch. And now I have my rectangular array that's 2 by 3 or 3 by 2, depending on if I look at vertical columns or horizontal rows. And this works for any whole numbers. I can break each side up into pieces that are 1 inch long, and then I get a whole bunch of 1 by 1 inch squares, or square feet, square yards, whatever our unit is. And then I have an array of these units that I need to count up. And we know how to find an array. We multiply either the length by the width or the width by the length. Relating this back to my commutative property, let's suppose I have a rug that's made from 3 rows of 5 squares each. So in this rug, we have 3 rows. So that tells me how many groups I have. And each row has 5 squares. So that tells me how many things are in each group. So here's my 3 rows, and then we're going to divide this up into 5. So here's 1, 2, 3, and then 4 and 5. So we can see that this would be 3 times 5 because, like I said, this is the number of groups I have, the number of things in each group. But from this picture, we can see that this is also 5 columns of 3 squares. And that would be the exact same rug. And here I have 5 groups with 3 each. So we do have 3 times 5 is the same thing as 5 times 3.